If you look closely at the bushes in your own backyard, you might find something that looks like it dropped out of a flying saucer, a creature with a triangular head that swivels around on a remarkably flexible neck to stare right back at you. Tucked away among the leaves and flowers, it holds its long, spiked forearms folded tightly against its chest. Early human observers saw this upright, stationary pose and thought it looked reverent, earning the insect its common name, the praying mantis. For centuries, people viewed it as a peaceful, almost pious curiosity of the garden. But the undergrowth is a chaotic, hyper-competitive ecosystem. Spiders, wasps, and beetles are in a constant, frantic scramble for calories. The mantis survives this miniature jungle through total abstention from the chaos. It doesn't sprint after grasshoppers or chase down flies. Instead, it waits. It can sit perfectly still for hours on end, letting the frantic food chain come directly to it. That absolute stillness is an active camouflage. By remaining entirely motionless, the praying mantis hides in plain sight, engineered over millions of years to be a highly efficient ambush predator. The question is how a creature that barely moves manages to secure a constant supply of fresh prey. The process begins with target acquisition. Unlike most insects, the mantis possesses a highly articulated prothorax, the long segment connecting its head to its legs. This creates a flexible neck that can rotate nearly 180 degrees. It can scan its entire surroundings and track incoming prey without twitching a single muscle in its abdomen. Mounted on the corners of that triangular head are two massive bulbous compound eyes. Each one contains up to 10,000 individual photoreceptor units called ommatidia. While many insects use compound eyes simply to detect motion, the mantis uses them for precise three-dimensional stereo vision. This animated diagram illustrates how their stereoscopic vision works. Because the eyes are spaced widely apart, each eye views an approaching insect from a slightly different angle. The intersecting lines of sight from these two distinct vantage points allow the mantis's brain to triangulate the exact physical distance to the target. As you look into those eyes, you'll often notice a dark spot that seems to follow you. That is a pseudopupil. It happens because the ommatidia you are looking at dead center absorb the incoming light, rendering them pitch black, while peripheral cells reflect it away. This entire optical array acts as an organic rangefinder. The mantis never guesses, and it never lunges out of desperation. It remains entirely frozen until the biological mathematics of its vision confirm the target has crossed the threshold into lethal range. Once the target is within range, the mantis deploys its primary weapons. While its middle and hind legs are built for walking and gripping branches, the front limbs are entirely dedicated to capturing prey. Looking at this schematic of the mantis foreleg, we can see the specific mechanics of the trap. In a typical insect, the base segments, the coxa and trochanter, are short and inconspicuous. But here, they are elongated and fused, acting as a massive, spring-loaded hinge that extends the reach of the strike far beyond the insect's body. The outer segments of the leg, the femur and the tibia, are lined with sharp, tooth-like spines called tubercles. When these two segments snap shut around a grasshopper or a fly, the spikes interlock perfectly, acting as a vise that impales the target and prevents it from wriggling free. The foreleg has sacrificed its role in basic locomotion. It operates purely as a specialized, inescapable biological cage built to snatch and secure a live meal. Occasionally, a hungry mantis will need to close the distance to its target. When it does, it steps forward while rhythmically swaying side to side. To the motion-sensitive eyes of a fly or a spider, this rhythmic rocking mimics a dry leaf blowing in the wind, allowing the mantis to sneak into the strike zone undetected. The ambush reaches its climax when the prey finally touches down. The mantis stops swaying, it locks its posture, anchoring its four walking legs firmly to the branch, and its visual targeting system calculates the final distance. The spring-loaded arms deploy. In a fraction of a second, the coxa extends, the spiked femur and tibia shoot forward, and the trap snaps shut. The prey is snatched out of the air and pulled back to the mantis's mandibles before it even registers the attack. Hours of absolute silent stillness culminate in an explosive burst of kinetic energy. The insect survives precisely because of this stark duality between patience and sudden, extreme violence. Once the target is secured, the feeding process begins immediately. The mantis uses its sharp mandibles to consume the prey alive, efficiently digesting the fresh protein. Afterward, it meticulously cleans its spiked forelegs and antennae, resetting the trap for the next ambush. Humans have closely observed this biological weaponry for centuries. In China, observers studied the precise hooked hands and rapid strikes of the insect, translating those movements into dedicated, highly structured martial arts systems known as Northern and Southern praying mantis kung fu. That same calculated efficiency also tapped into deep-seated human fears. The unfeeling alien stare and relentless hunting style made it a natural villain in 1950 cinema, easily scaled up into a towering monster to terrorize moviegoers. Yet its biological adaptations go far beyond its famous front arms. When male mantises take flight at night to find a mate, they rely on an auditory chamber located in the center of their chest. This single ear is tuned to detect high-frequency ultrasound. If it registers the echolocation clicks of an approaching bat, the mantis abruptly stops flying horizontally and spirals down into the safety of the grass. It is a creature defined by absolute precision. From its stereo vision targeting sensors to its spiked spring-loaded snares and its built-in sonar evasion system, the praying mantis is a masterpiece of natural engineering. It proves that in the wild, the deadliest threat is often the one that knows exactly how to remain completely invisible.